Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today in mathematics, we are going to move on to something quite different from what we have been doing in the past couple of weeks. We'll be studying plane shapes. Specifically, we'll be looking at triangles, the different types, and how they are around us. But first, we'll begin, as is our usual practice, with correction to the previous homework. In our last lesson, you were asked to study these diagrams and find the missing angles. Now, I'll take my time to solve this for you one by one. Number one has this diagram picturing A on the same line with B and then 56 on the other side. Now, the correct answer to this will be A is 56 and B is 124. And that is because A and 56 are corresponding angles. You will recall that this is the F facing backwards. So if this is 56 above the line, then this will also be 56 above the line. Now, B and 56 are interior opposite angle. This, my friend, is the U. This is the U. And so B and 56 will add up to 180 degrees. So if this is 56 already, then I will have to add 124 to it to make 180 degrees. And that is why A is 56 and B is 180 degrees. Our learning objectives will be as follows. By the end of this lesson, you should be able to name different triangles based on the properties of their sides. Now, there are different types of triangles. You've probably seen them, but you do not know the differences between them. Today, Uncle Agbaje will show you how different indeed they are. So you should be able to name different triangles based on the properties of their sides. You should also be able to name different triangles based on the properties of their angles. And finally, you should be able to state the properties of different types of triangle. What makes this triangle to be different from the other? So let's just go right into it. Now, polygons we have discussed in our previous lessons are plane shapes that have straight sides, and these sides are closed. Now, the simplest polygon you will ever get is a triangle. It has three sides. Now, a triangle is the simplest polygon because it's not possible for you to, have two straight lines and close it. It will not give you a plane shape. So the simplest you will get will be to add a third side and it will close up. So any shape that has three sides, three straight sides, is what you call a triangle. You can come in different form. You can come like this. This is a triangle. This is a triangle. This is a triangle. As long as there are three sides. But you will agree with me that these triangles are different. What are their names? We'll learn in the course of the lesson. So let's move on. All triangles must have three sides. I've said that. And the sides will be straight. They also have three angles, and these are the three angles. That's one angle. The corners are the angles. This is another angle, the corner, where two lines meet. This is another angle, the corner, where two lines meet. So you would not find any other angle apart from these three. What other properties of triangles do we know? The sum of all angles in a triangle will always give you 180 degrees. We have talked about angles in a triangle in our previous lessons. So now let's go into specifics. Let us now look at the types of triangle based on the properties of their sides. The first one that we are going to be considering is the one we call the scaling triangle. This on the board is a scaling triangle. What are the properties? Let us see. First property is that none of the sides are equal. None of the sides are equal. This side here let's call this one 1, 2, 3. Side 1 is not equal to side 2. You can see that side 2 is longer than side 1. And the side 3 is obviously the longest of them all. And so I have this single marking for side 1, double marking for side 2, and these triple markings for side 3. Let's look at the next property. None of the angles are equal. None of the angles are equal. And obviously, this angle is the smallest of them all. This angle is the next smallest one. And this angle will be the largest one. So none of the angles are equal. None of the sides are equal. Very easy to remember that for a scaling triangle. Let's see the next. It has no line of symmetry. What is a line of symmetry? A line of symmetry is a line along a plane shape, a line along which you fold a plane shape so that one part will cover the other part and there will be no leftover. I'll demonstrate. This is a scaling triangle. This is a scaling triangle. None of the sides are equal. Now, if I fold along this angle into two parts, you see immediately that the two parts are not equal. This side is bigger than this part, and that's why one is overlapping. Now, if I fold along the other angle as well into two parts again, you see that this one, the one here, is bigger than this one. That is why it is overlapping on this side. If I fold along the third side, fold quickly here, you immediately see that it is still overlapping below here. So there is no line that there is no way I can fold this triangle in such a way that one will completely cover the other part. That means it has no line of symmetry. One part will be unequal to the other part. What else does it have as property? It has rotational symmetry of order 1, and that means that if I turn this triangle round in 360 degrees, it's not going to look like this again until it comes back to the starting point. Let's see. See? The only way it's going to look like this is when it comes back to the starting point. Let me show you that again here. Now, this triangle, this is it. It's not going to look the same again like this. If I turn it this way, it's not looking like the first one. If I turn it this way, it's not looking like the first one until I come back to the first one on top. Let's take that again. I'll mark that top for you so that you can see. Now, I hope that you can see the black marking on top. If I turn it this way, it's not looking like the first, when I had the marked part on top. And if I turn it this way, it's not looking like when I have the marked part on top until I come back to this position. So it's only once that it looks like this. And that means rotational symmetry of order 1. It looks just like this once when I turn it around. You will see others as well. Now let's move on to the next triangle. This triangle is called an isosceles triangle. Perhaps you're familiar with it. Let's look at the properties. Two of the sides are of equal length, yes, and it's quite easy to see those two sides that are of equal length. We have given them markings like this. So when you see markings like this on a triangle, it means that the two sides, if this is A and this is B and this is C, then line AC and line AB are equal. That's why we have the same markings for them. Let's look at another property. Two of the angles are equal. Now the two angles that are equal are A and C. These are called the base angles sometimes. To know the angles that are equal, just trace the sides that are equal. Trace the sides that are equal, trace them down. This side is equal to this side. So at the end of the two sides, we will have the two angles that are equal. So A and C are equal. B is not equal to them. That's why we don't mark it the same way. These ones will get double markings and that one will get a single marking. What other property does it have? It has one line of symmetry. Now you will see what I mean by one line of symmetry. This is an isosceles triangle. So let me just mark the top for you. I've marked the top so that when I want to rotate. Now let me fold along this side. Now you see that this side, nothing is overlapping on this side. If I turn it back, nothing is overlapping on this side. So this line in the middle that divides it into two equal parts is what you call a line of symmetry. And I'll just show you that. So this line that runs down the center is called the line of symmetry. If I fold the shape along this line, it will be equal on both sides. Let's check out the other sides. Is it a line of symmetry or not? Let's see. If I fold along this angle, you see that there is an overlap. So it's not the line of symmetry. If I fold along the third angle, you will see that there is an overlap, obviously. So they are not equal. So this is the only line of symmetry, this black one that I have drawn for you here. And that is why an isosceles triangle has just one line of symmetry that runs down in between the two sides that are equal, straight to divide the two angles that are equal. That's the line of symmetry. Let's see what other properties it has. It has rotational symmetry of order 1. And that means that if I rotate it like this, now let it go. If I point this side on top, it's not looking the same. If I turn it around and put this one on top, it's not looking the same as when I started. The only time it's going to look the same as when I started is when I put the marked part on top. Let's move on. Now this one, the equilateral triangle. The equilateral triangle is a very simple triangle to recognize. Equi means equal, lateral means side. So obviously, what that means is that all the sides are equal. So if this is AB, A, B, C, then AB is the same thing as BC, is the same thing as AC. So if this is 7 centimeters, for instance, then this will also be 7 centimeters, and this will also be 7 centimeters. And because all the sides are equal, all the angles are also equal. That is, this angle is the same thing as this angle, this is the same thing as this angle. So if I give it single marking, it has to be single marking all through. And if I give it double markings, it has to be double markings all through, because they are equal. And because all the angles in a triangle must add up to 180 degrees, if I divide it into 3 equal parts, I'll get 60 here, 60 here, and 60 here. So all the angles are equal and they are 60 degrees each. Let's see the next property. It has 3 lines of symmetry, and that means that I can divide it into 2 equal parts along 3 lines. Let's see what that means exactly. This is an isosceles triangle. I want you to look at it very well because I'm going to be rotating this. Now if I fold it along the angle on top, now you immediately see that there is no overlap here, and there is also no overlap here. So which means that this line in the middle is a line of symmetry. I'll just draw that. A line of symmetry. So let me fold it along this line. Now, no overlap, and that means that this is also a line of symmetry. So I'll just draw that line for you to see. And finally, if I fold it along this line, you can see that there is no overlap. And if I turn it around, no overlap, showing that this line also is a line of symmetry. So these are the 3 lines of symmetry. An equilateral triangle will have 3 lines of symmetry running down the middle, and they meet at one point. Okay, so then it has rotational symmetry of order 3. And that means that if I turn it around 3 times, you will see that it looks the same in exactly 3 points. This is the first point. Now if I turn it around this way, you observe that you cannot distinguish between this point like this or this point like this. Now which one is A, which one is B? It's looking the same. Now if I turn it around the 3rd time, it's still looking the same. So if these are our starting points, let me give it double marking like this. Then if I turn it this way, it's looking exactly like when I started. And if I turn it around like this, it's looking like when it started. So if I turn it around in 3 ways, it's going to look the same in 3 ways around the circle. So that means it has a rotational symmetry of order 3. Now moving on, let's now evaluate what we have learned so far. You have 1 minute to study this and fill in the gaps. Dash has one line of symmetry. The longer side of a right angle triangle is called dash. Dash has no sides equal and no angles equal. Dash has 3 lines of symmetry. Dash has all its sides and angles equal. You have 1 minute. Begin. Alrighty then, eyes on me. I believe this was easy peasy for you. Let's now see the answers. An isosceles triangle has one line of symmetry, as we have pointed out, this one. The longer side of a right angle triangle, of course, is an hypotenuse. It's called the hypotenuse. The first triangle that we treated today was a scaling triangle. None of the sides are equal and none of the angles are equal. Equilateral triangles has 3 lines of symmetry. That's this one. And it also has all the sides and angles equal. Did you get them right? I believe you did. Wonderful children you are, and I will celebrate you with a chair. Now I want you to copy this and complete them during your leisure. You have to write 2 properties for each of the following: isosceles triangle, scaling triangle, equilateral triangle, and right angled triangle. Hello children, you're welcome back to this segment of the show. It's the Magic Tuesday segment where I teach you tips and tricks on how to navigate the field of mathematics very, very easily. Last week we learned about how to multiply numbers by just drawing lines and counting dots. But that method was for low digit numbers. We call it the Japanese method. Today I want to teach you the Chinese method of multiplying numbers. For example, we want to multiply 48 by 36. So first we begin by drawing a rectangle, put a number on top, 48, 36 on the side, then put a line in between each number, and remember to partition each box like this. Now let me start from here this time. The number on top is 4, the number at the side is 3. That's 4 times 3, I get 12. Let's come here so that you know that we can start from anywhere. The number on top is 8 and the number to the side is 6. 8 times 6 is 48. Let me start here now. 8 times 3 is 24, and here the number on top is 4, number to the side is 6. So 4 times 6 is 24. So you know all we have to do now is to add along the diagonal, and the addition is, for this diagonal I get 8, 4 plus 4 plus 4 is 12. So let me just show you again how we are adding. You follow the line. Follow the line. So it's as simple as that. So 8 here, 12 here, 6 here, and then 1 at the end of this one, just like we did last week. Now, the next thing to do is to, this one has 12, 2 digits, so you carry 1, and that 1 comes to the next place value. 1 plus 6 gives us 7, and then your final answer is 1000. 728. This is called the Chinese method. It doesn't confuse you as to where you're going to put one number or the other. Just pick a box, multiply the number on top, and multiply the number to the side, and voila, you get your answer. We'll continue with this by God's grace on next week's Magic Tuesday. Till I come your way again, I remain Uncle Agbaje. Over now to Uncle Popo for the basics general studies lesson.